In September 2009, Belwind started construction of 55 wind turbines on the Bleibank, 46 kilometres off the coast of Zeebrugge. It's the furthest offshore wind farm in the world and in the deepest water. An international team of specialists worked 24/7 to complete this huge project by the end of 2010. The foundations of the wind turbines and the offshore high voltage station are ready-made 7 centimetre thick steel monopiles. These monopiles are easier and faster to put in place than lattice towers or concrete foundations. The gigantic hollow tubes have a diameter of 5 metres and can be up to 72 metres in length. The monopiles weigh 300 to 550 tonnes. Instead of transporting them by ship, we float them. Both openings are sealed airtight with a hydraulic plug. Weather conditions largely determine how quickly the works progress. Our tug only goes out when the waves are less than 1 metre high. It takes approximately 6 hours to get to the Bleibank. At the sandbank, the monopile is taken over by the massive crane ship Svanen. With a lifting capacity of 8,700 tonnes, it's the strongest floating crane in the world. Because the sea at the sandbank is 20 to 35 metres deep, the length of the foundation poles also varies. They're between 50 and 72 metres in length. Svanen's special grab hook lifts the monopile into the air. Our technicians determine the position to the nearest centimetre using global positioning technology, which requires 1 hour of extreme concentration. Before the pile is hammered into the seabed, special sound signals are emitted to drive away any marine animals. After removing the airtight seals, the monopile is moved to the desired location. We regularly check whether the pile is at a right angle. An ordinary spirit level is still useful. It takes about 3 hours to hammer a pole 35 metres into the seabed. The last blows are about 12 times more powerful than the first. When it's all quiet again, only the top of the foundation pile is sticking out of the water. In all, there are 55 piles for the wind turbines and 1 for the high voltage station, which will collect the power generated by the turbines. Currents can wash away the seabed around the piles and thus affect the stability of the turbines. To halt this erosion, rocks are dumped around the piles over a wide area. Our full-pipe ship dumps about 1,800 to 2,700 tonnes of rock around every pile, depending on the location and the sea depth. A ready-made connecting piece about 4 metres in diameter, 25 metres high and weighing 167 tonnes is placed on the piles. Every connecting piece has a mooring area, a ladder, platform, access door and pipes for the power cables to protect them against the waves. Our jack-up platform transports the connecting pieces 3 at a time from the port to the Bleibank, a trip that takes 6 hours. At the sandbank, the jack-up platform anchors itself to the seabed. The 70-metre-long legs extend and the platform jacks itself up from the water. This means it's no longer affected by wave action, and it's a stable work surface for very precise crane work. A crane lifts the connecting piece and slides it over the foundation pile, so that it overlaps about 7 metres. The hollow space between the narrow foundation pile and the wide connecting piece is filled up with concrete. This anchors the connecting piece on the foundation. foundation plus a connecting piece are now 65 to 90 metres in length. Most of it is in the seabed and underwater. The platform is raised 17 metres above sea. Because it's more difficult to work at sea, the turbines are assembled mostly on land. The two parts of the tower are put together and the nacelle and the rotor head are assembled. The entire installation is electrically tested before it's assembled at sea. Following assembly, the jack-up platform transports two upright towers, two nacelles and 6 loose rotor blades to the wind farm. The 55-metre high tower with the nacelle and the rotor head on top are positioned on the yellow connecting piece first. This is the size of a bus and weighs 120,000 kilos. Then the 3 rotor blades, 44 metres in length, are positioned in the rotor head. In good weather, the turbine can be assembled in 6 hours. At the highest point, the ends of the blades stick out 117 metres above the sea. Including the foundation piles, the total height of the construction amounts to almost 190 metres, about twice as high as the Atomium in Brussels. The power generated by the 55 turbines is collected in the offshore high voltage station in the middle of the wind farm. It contains a massive transformer, has 5 250 square metre stories and weighs 1,100 tons. When the station was completed, it was transported from the production site in Hoboken in Antwerp via the Scheldt to the port of Zeebrugge. If the sea is calm, it can be transported to the sandbank. Up to 3 times we had to abandon transport and return to Zeebrugge. Finally, when the sea was very calm, we were able to venture out and anchor the high voltage station to its monopile. A daring feat which combines immense power with extreme precision. The safety of our people comes first. The station was built by BOS, a temporary unique joint venture of Belgian companies, CG Holdings Belgium, Fabricom GDF Suez and Immans Staalbouw. It's unique in that it's a low-maintenance station, which in turn will be connected with a second high-voltage station on land, with the more sensitive electrical components. This technological novelty considerably limits the offshore maintenance work and ensures the wind farm is operational longer in between services. The generated power of the 55 turbines is led to the high voltage station via infield power cables, which can handle 33,000 volts. Our cable ship transports the bobbins and tailor-made cables to the wind farm. The turbines are connected in loops of 10 and 5, and from every loop there's an infield cable to the high voltage station. The maximum voltage of 33,000 volts is converted in the high voltage station to 150,000 volts to minimize the loss during transport to the mainland. From the high voltage station, the power is transported to the mainland via one export cable that can handle 150,000 volts. The cable is 52 kilometers long and 30 centimeters thick and weighs 80 kilos per meter. It's on one gigantic bobbin or turntable that weighs 4,700 tons. The cable is rolled out in one piece and then buried into the seabed, up to 9 meters deep. The last kilometres before the coast, smaller vessels take the cable and a winch pulls the cable on land via a 2-metre deep trench. 2 metres under the sand, the export cable is connected to the land cable, which is already buried under the resort of Zeebrugge. For reasons of safety, the cables are covered with a strong protective plate and up to 3 metres of sand, so that nothing of the installation is visible. The 3-kilometre-long land cable goes to the booster transformer station, which adds the power to Elia's transmission grid. And that's how the electricity ends up at households and companies. The forces of nature complicate offshore working. The size of the wind farm, the considerable distance to the coast and the sea depth made the challenge for Belwind even more complex. Still, our team managed to complete the farm in a record time of 15 months. We expect Belwind to produce green electricity for 175,000 Belgian households and emit 270,000 tonnes less carbon dioxide. Thus, Belwind ensures Belgium will achieve the European 20-20-20 targets for renewable energy. And that power supply in the future is guaranteed.